So problem number 10. Problem number 10 in this case is asking you to find the values of k for which this series converges. N to the 1/2 over the cubic root of n to the k plus 10n. So we need to think about this for a little bit. Applying a series test is probably a good idea, but we also need to figure out what we're going to compare it to and how we're going to figure out where the results fit in. So what I'm going to do is I'm going to start with a comparison test in this case. I'm going to say that if I want this to converge, I can compare it to the following. So my a sub n is n to the k plus 10 to the n. I'm going to say that for this to converge, I want to compare this to n to the 1/2 over n to the k over 3. So basically what I did is I said that this will be larger than this term, so I'm going to compare it to k over 3, so the cubic root of n to the k. Now because this denominator is smaller than this number should always be larger, so therefore it should hold for all n. So now what I'm going to do is I'm going to kind of focus on this term a little bit, because I know that if this term is convergent, this will also be convergent. But I need to figure out what value of k is going to give me convergence. So I can rewrite that term as n to the k over 3, and if I wanted to go ahead and combine these terms, what I can do is I can actually bring this n to the 1/2 down as 1 over n to the negative 1/2. Now, again, all that's doing is it's kind of the opposite that you would be doing if it was positive on the bottom and you wanted to bring it up to a negative power. If I wanted to bring this up from positive to negative, all I have to do is switch the sides and switch the sign. So, when I have n to the k over 3 times n to the negative 1 over half, powers of the same base, I can add the powers together, combine them into one term. So this becomes k over 3 minus 1 over 2. Now, I know that all this series is a p-series. So I know that whatever my power is has to be greater than 1 for convergence. So what I'm going to do is I'm going to say that k over 3 minus 1 over 2 has to be greater than 1 for this to converge. Now it can be any number greater than 1, so technically this could go anywhere to infinity. But I need to figure out what my minimum k value is that's going to satisfy this equation. So if I go ahead and solve this out, k over 3 is greater than, so if I add the 1/2 to the other side, I end up with 3 over 2. And if I multiply the 3 over, k is greater than 9 over 2. So what this tells me is that as long as k is greater than 9 over 2, this series will always be convergent. So if I wanted to write that in interval notation, I could say that my minimum bound would be 9 over 2, non-inclusive of course, because if it is 9 over 2, then it falls right on the margin and it becomes divergent. So I don't want it to include 9 over 2, but it can be any number past that. And there's no upper limit in this case. It can be anything greater than 9 over 2, so my upper bound is infinity. And of course non-inclusive to infinity, because that's always the way the notation goes. Looking at my answers, this answer is letter B.
The Teaching Center, UF's Learning Resource Center.